Hi everyone and welcome to another video of vector mechanics. So today we're going to be looking at vector analysis for composition and resolution of forces. It's going to be a full video and a mega one for you, and I believe that after this video you actually have a firm understanding of this section. Alright, let's learn something new. So we'll look at another video. So today we'll look at vector analysis for composition and resolution of forces. So this is the process of finding out the resultant force of a number of given forces. So when several vectors are acting on an object of mass m kilograms, the resultant or net vector F is calculated as the vector sum. So for example, if we have different forces that we're actually adding up together, so have the resultant vector being equal to V1 plus V2 plus V3 and so on, depending on the number of forces given. Alright, so let's look at some questions to understand this better. So being told to find the resultant of each of the following forces. So question 1, 2i plus 3j plus 3k newtons and 2i plus 4j minus 8k newtons. So how do we solve this? So I'm going to put them in column form to actually make them easier for me to actually look at and add together. So for example, I'm going to have the resultant force F being equal to column 2, 3, 3 plus column 2, 4, negative 8, of which, as we've said before, I'm going to add all the different terms that actually share the same variable or at the same position. Like here I'll have 2 plus 2, which shall give me 4. I'll have 3 plus 4, which will give me 7, and I'll have 3 plus negative 8, which is the same as 3 minus 8, which will give me negative 5. So therefore the resultant force shall actually be 4, 7, negative 5 newtons. Alright, so part 2. I have the vector 7i minus 4j plus 3k newtons, and then the other vector 5i minus 2j plus 8k newtons. The other is I minus k newtons. So let's arrange these in column form. So now the resultant force F shall be, so for this I'll have 7 negative 4 3 plus 5 negative 2j 8k. Now when I come to this, I actually see I only have an I and a k, so I actually don't have the j value. So that actually means that the coefficient in front of the j was actually a 0. So that means here for the I have a 1, and then for the j I'm going to have a 0, and then for the k I can set I'll have a negative 1. So the resultant shall be 7 plus 5 plus 1, which is 13, negative 4 plus negative 2 plus 0, which is negative 6, and then 3 plus 8 plus negative 1, which is 10, and that is the resultant force. So question number 2, we're being told that the resultant of the forces 5i minus 2j newtons, 7i plus 4j newtons, and ai plus bj newtons, and negative 3i plus 2j newtons is the force 5i plus 5j newtons. Then we're being told to find a and b. So in this example we've been given the resultant already, and we just have to find the unknown values in some of the forces given. So we're going to let F be the resultant force. So remember that resultant force shall be the sum of all the forces. So this is what we have. So remember, where there is the resultant force, we know the resultant force is 5i and 5j. So that means that every value here added up together should give me what I have right there. So when I add these together, I'll have this. So let's look at the top column right here. So I have 5 plus 7 plus a plus negative 3 being equal to this 5. And then I can see that when I add this together, I'll have 5 plus 7 minus 3, which will give me 9, and then plus this a being equal to 5. So I'm going to have a being equal to negative 4, because 5 minus 9 is negative 4. So next I can actually look at those at the lower section of the column. So I'll have it as negative 2 plus 4 plus b plus 2, which is equal to this 5. So when I total those together, I'll have 4 plus b being equal to 5, of which b shall now be equal to 1, and those are the values of a and b. In question 3, we're being told that the resultant of the forces 5i minus 2j plus 2ak newtons, 2i plus j plus 4k newtons, and bi plus 2j newtons is the force 8i plus cj plus 14k newtons. Find a, b, and C. So again here we've been given the resultant force. So this is what we have. We're going to let F be the resultant force, and then we're going to arrange them this way. So this is what we have. So now we know the resultant force is 8C 14. And then here we have 5, -2, and then 2A, like we have there. 2, 1, 4, as we have there. Then we have B, 2. Now you can set we don't have the K, so that means that the coefficient in front of the K is 0. So that's why I have a 0 right here. So let's total everything. So at the top we'll have 5 plus 2 plus B shall be equal to 8, of which we'll have 7 plus B being equal to 8, and B shall actually be equal to 1. So next row we'll have -2 plus 1 plus 2 being equal to C, of which C is going to be equal to 1. Then lastly we have 2A plus 4 plus 0 being equal to 14, of which we'll have 2A plus 4 being equal to 14. Then 2A is 10, and A shall now be equal to 5. And those are the values of A, B, and C. So next question is a question from UNEB 2006, and this was question number 3. So being told that the resultant of the forces F1 is equal to 3I plus A minus CJ newtons, F2 is 2A plus 3CI plus 5J newtons, and N, and F3 is 4I plus 6J newtons acting on a particle. So the resultant of those forces acting on a particle is the force 10I plus 12J newtons. So part 1 we're being told to find A and C, and then in part 2 we're being told to find the magnitude of the force F2. So let's solve this. So first of all we're going to let F be the resultant force, and then we know that F shall be equal to F1 plus F2 plus F3, of which we'll have 3, then A minus C plus 2A plus 3C, and then 5 plus 4 and 6 being equal to 10, 12, as you can see right there. So you can already see that we'll have at the top we'll have 3 plus 2A plus 3C plus 4 being equal to 10, of which I'll have 2A plus 3C is equal to 3 as equation 1. So secondly I'm going to compare the next row. So I'll have A minus C plus 5 plus 6 being equal to 12, of which I'll have A minus C being equal to 1. So from equation 2, I'm going to make A the subject. So A shall actually be equal to 1 plus C. And that shall be my equation 3. So I'm going to substitute for A into equation 1, and then I'll have it this way. So putting the value of A into equation 1, I have 2 into 1 plus C plus 3C is equal to 3, which I have 2 plus 2C plus 3C is equal to 3, of which 2 plus 5C is equal to 3. Then I'll have 5C being equal to 1, of which C shall be equal to 1 over 5. Then I'm going to substitute for C into equation 3, and I'll have A being equal to 1 plus 1 over 5, of which A shall be equal to 6 over 5. So in part 2, we're being told to find the magnitude of force F2. So remember that F2 was equal to 2A plus 3C and then 5 next. But remember now we know the values of A and C. So now we're going to substitute those in, and this is what I'll have. 2 times 6 over 5 plus 3 times 1 over 5. So I'll have 2.4 plus 0.6, which is 3. So I'll have column 3 and 5. Alright, so next I need to find the magnitude of that force F2. So how do I find the magnitude? So to find the magnitude, I'll find the square root of this value here squared plus this value next squared. So 3 squared plus 5 squared, of which I'll have it as root 34 newtons. Now when I put that and in my calc, I'll have 5.831 newtons. Right, so therefore the magnitude of the force F2 is 5.831 newtons. Therefore, the magnitude of the force F2 is 5.831 newtons, and that is the answer we're looking for. Alright, so next question, we're being told to find the magnitude and direction of the resultant of the forces 2I plus 3J newtons, 5I minus 2J newtons, and then negative 3I plus 3J newtons. So these are also two-dimensional vectors where there is only I and J. So let's find the resultant force. So we're going to let F be the resultant force. Then F shall be equal to 2, 3 plus 5, negative 2 plus negative 3, 3. So when I total this together, I'll have them as 4, 4. So now I know the resultant force. So now to find the magnitude of the resultant force, I'll have F as being equal to the square root of 4 squared plus 4 squared, which is 32. So I have root of 32, which is 5.657 newtons. So that is the magnitude of the resultant force. But remember, now we're being told to find the direction of the resultant force. Now, to find the direction of the resultant force, we're going to make use of a vector triangle. So we draw it to determine the resultant vector's direction. Now, as you can see already, here is the resultant vectors point in the positive direction. So as you can remember, when we represented this on x and y axis, you can see that the 4 represents the value on the x axis, then this other one represents the value on the y-axis, and if it was 3-dimension, the next value would actually represent the value on the z-axis. So now we have the x and y. So now we can see that the x value is positive. So let's represent this. So as you can see on the horizontal, the x value is positive. So you remember that positive is towards the direction of the right on an axis. So that's why it's pointing into the right hand side direction. Then you also remember that the positive 4 for the y is pointing upward. So positive is towards the upward direction in the y-axis. So that's why we have it that way. And then we're going to have this as the resultant force right there. Then we have now here the angle theta, which is the direction of this resultant force. So to find theta, we'll use it as tan inverse of 4 over 4, because tan is opposite over adjacent. So this is what we have. Now theta shall be equal to tan inverse of 1, of which theta shall be equal to 45 degrees. So therefore, the magnitude of the resultant force is 5.657 newtons in the direction 45 degrees to the horizontal. Question 6. So we're being told to find the magnitude and direction of the resultant of the forces 4.3 newtons and then -1, -5 newtons. So how are we going to solve this? So we're going to do the exact same thing. So we're going to let F be the resultant force, and then we can see that we'll have F, then we have 4.3 plus -1, 5. So F shall be 3, -2 if we total the 2. Now to find the magnitude of the resultant force, I'll have it this way. So I have the root of -2 squared plus 3 squared. So I have it as root of 13, which is 3.6 newtons. Now to find the direction of the resultant force, I'm also going to represent it on the vector triangle. But now there's going to be some little bit of a difference. So now as I can see, I'm going to have I have a +3 on the y-axis. So now that's why it's pointing towards the right. Then I have a -2 towards the y-axis. I mean a +3 towards the x and then a -2 towards the y. So that's why it's actually pointing downwards, as you can see right here. So this is now my resultant force right here, as you can see. Alright, so to find the direction theta, it shall be equal to tan inverse of -2 and 3. So now in this case, we're going to consider both of them to actually be a positive, because we're not going to have a negative angle. So what we're going to have is 33.7 degrees. So therefore, the magnitude of the resultant is 3.6 newtons in the direction 33.7 degrees to the horizontal. Right, so next question is a question from UNEB 1999, and this was question 2. So being told that 4 forces AI plus bracket A minus 1J newtons, 3I plus 2AJ newtons, 5I minus 6J newtons, and -I minus 2J newtons act on a particle. The resultant of the forces makes an angle of 45 degrees with the horizontal. Find the value of A and hence determine the magnitude of the resultant force. So in this case, we've already been given the direction. As you can see, we already have 2-dimensional vectors, as you can see right there. So we are being told to find the value of A and to determine the magnitude of the resultant force. So what are we going to do? Alright, so let's solve this. So first of all, I can see that I'm going to total up everything to get the resultant force. So I'll have it this way. And then I can see that if I sum up everything, I'll have 7 plus A and 3A minus 9. So this shall be my resultant force with the unknown values, A, as you can see right there. So now that I know the angle the resultant makes with the horizontal, I'm going to represent this on a vector triangle. So this is what I have, the vector triangle with all the resultant forces, as you can see right there. So now we know that the angle, the direction of the resultant force is 45 degrees. So remember that we always had theta being equal to tan inverse of the opposite over the adjacent. So now I'm going to have 45 degrees being equal to tan inverse of 3A minus 9 over 7 plus A. So now I can take this tan to this side and I'll have tan 45 being equal to 3a minus 9 over 7 plus a. But tan 45 is 1, so I'm going to cross multiply. So when I do that, I'll have 7 plus a being equal to 3a minus 9, of which I can collect like terms. So I'll have 7 plus 9 being equal to 3a minus a. So I'll have 16 being equal to 2a, and then a shall actually be equal to 8. So now I know the value of a as 8. So this means that to find the magnitude of the resultant force, that means now I have, so now right here it means that this top value on the x shall actually be equal to 7 plus a, which is 7 plus 8, and I know that will give me 15. Then down at the bottom I have 3 times 8, which is 24. 24 minus 9, I believe that is 15, as we shall see. So to find the magnitude of the resultant force, this is what I end up having. So substitute for a, then I'll have it as root of 15 squared plus 24 minus 9, which is also 15 squared. But 15 squared is 225, and this will also be 225. So I have root of 225 plus root of 225, which is root of 450. And then the answer is 21.2 newtons. So therefore, the magnitude of the resultant is 21.2 newtons, and that is the answer. Question number 8. We're being told that a force of magnitude 5 newtons acts in the direction with unit vector 1 over 5, 3i plus 4j, and force B of magnitude 13 newtons acts in direction with unit vector 1 over 13, 5i minus 12j. Then we'll be told to find the resultants of the forces A and B. Alright, so now let's first find that force A, as you can see right there. So as you can see, we've already been given the force in terms of our quantity, and then we've been given the direction, as you can see. So direction with unit vector is 1 over 5, like as you can see right there. So usually whenever we wanted to convert a certain quantity that is given into a vector form, we always multiply the direction by the unit vector. But as you can see already in this case, we already have the direction with unit vector already given in that form. So that means we just multiply this 5 into that to get the force F A. And then we'll have the answer as 3i plus 4j, because this and this cancel. Then to find that of force B, we'll have it as 13 being equal to 1 over 13, and then 5i minus 12j. So this and this cancel, and we'll be left with 5i minus 12j. So therefore, to find the resultant force, we'll have it as F being equal to 3, 4 plus 5 negative 12, of which I'll have it as 8 with negative 8 at the bottom. And that is the answer that we're looking for. And that is the resultant of the forces A and B. Alright, so next we're being told that a particle moves through a displacement of 2 meters when acted upon by two forces, F1 and F2. Find the work done by the resultant force if F1 is I minus J and F2 is 10 newtons and acts in the direction 4i and 3j plus 3j. Now as you can see, force 2 has been given in quantity form, so that means that somewhere along the line we'll also have to convert it into vector form. But force F1 is already given in vector form, so that means force F2 has to be converted. So first of all, force F1 is I minus j. Now to convert force F2 into vector form, we'll multiply the quantity itself times the unit vector of the direction. So this is what we'll have, 4i plus 3j over root of 4 squared plus 3 squared, of which F2 shall actually be equal to this. So if I solve this further, I'll have 2 times 4i plus 3j, which is the same as 8i plus 6j, and that is force F2 in vector form. So now that I have that in vector form, I can find the resultant force. So the resultant force F is bracket 1 negative 1 plus 8 6. So total those together and I'll have force 9 5. So now I can find the magnitude of that resultant force as being equal to the square root of 9 squared plus 5 squared, of which I'll have root of 81 plus 25, which is equal to root of 106, and the answer shall be 10.3 newtons. Alright, so lastly, we're being told to find the work done by that resultant force that we found right there. Remember, at resultant force, since it's given, we can now find the work done. And remember, that work done is equal to force times distance. So now we already know the force and the distance or displacement was given in the question. So work done is 10.3 times 2 meters, as you can see right there, and we shall have the answer as 20.6 joules. So the SI unit of work done is joules, so you have to put it that way, and that is the answer they wanted. Alright, I have an exercise for you. These are a few numbers you can try out to get better at the knowledge in this section. So feel free to try them out and then compare your answers to the answers that I've actually put in brown color, as you can see there in brackets. So pause this video, write down the questions and try them out, and I believe that they will really help you. So now the questions continue. That is question 4 now. So I encourage you to copy them down, try them out, and I believe that they will help you get better. Thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. I hope the numbers were sufficient for you. If this video was of help to you, feel free to give the video a like, a thumbs up, and then feel free to share the video with all those that you can and help them out if the video really helped you. And then you can leave a comment down in the comment section for me, and I'll get time to reply to you. Thank you so much for watching. I'll see you in the next video.